Hello, everybody, and welcome to the Blockchain Day, hosted together with Lisk and WeAreDevelopers. I'm super happy to have everyone here today, and for those joining also on the live stream now, super happy to have you on board. As you see, we're starting to gather up today here, and for those of you who haven't had your drinks yet and food yet, you know where to find them. And as for today, we have a couple of different activities, starting with Ishan, who is going to talk a little bit about Lisk and introduce Lisk and the blockchain application in JavaScript. So would like to welcome you on stage.
Saren. Hi, everyone. Welcome to Blockchain Day. I hope you're having a great time here. So yeah, I'm Ishan. I'm working as a lead SDK developer here at Lisk. And yeah, bit about my background. So I'm having 8 years of software development experience, and I have a background in distributed systems and services. And yeah, so before we dive into more profound discussions over blockchain, I want to quickly introduce Lisk and also introduce Lisk SDK. Okay. Okay, it's working too fast. Yeah, so what is Lisk? So Lisk is a blockchain application platform that allows developers to create scalar, modular, and interoperable blockchain applications using JavaScript. And LSK is the utility token that is being used in our network, which is used for various activities like transfer token, vote or unvote, delegate. And this LSK token is used in our network, which is managed by a blockchain application we call Lisk Core. This is the client, and this is powering Lisk mainnet and testnet from last 6 years. Lisk Core uses DPoS, which is delegated proof of stake, which is slightly different from proof of stake in the sense that it's more democratic, and here you can vote for the delegates, and then in the end, delegates are chosen based on the votes and the stakes they have to create any block. We have BFT, which is a Byzantine fault tolerance consensus algorithm for block finality, and also detecting and resolving forks in the network. Lisk Core is completely written in TypeScript, and it has its own CLI, which you can simply install using npm install Lisk Core. And yeah, you are good to go, and you just simply write Lisk Core start, your application starts. You can also use flags to connect to different networks like mainnet or testnet or betanet. And you can get Lisk over in all the major cryptocurrency exchanges. There are a few of them listed here. And once you acquire the Lisk, you want to probably store it in a safer place. So we have Lisk Desktop and Lisk Wallet, where you can save, you can keep your Lisk tokens. And Lisk Desktop has more functionalities in the sense that it is also acting as an explorer. And you can see whatever is happening in the network. Also, you can vote, unvote delegates there. Whereas Lisk Mobile is just is a Lisk wallet, and it's available on all the platforms. And also, if you want to use the browser-based applications to browse through the network, we have two popular explorers, Lisk Scan, Lisk Observer, which is developed and maintained by our community members. And yeah, there are also some other explorers as well, but these are the two popular ones which you can check out. So the question comes, why Lisk? So there are a lot of blockchain projects out there. Then why Lisk is different? So first of all, Lisk is open source, so all the products developed in Lisk are completely open source. Secondly, it's rooted in JavaScript, so that means that it enables the developers to write blockchain application by simply using JavaScript, which is one of the most popular languages in the world. It is customizable, so you can write piece of code or piece of logic that you can easily plug and play in the application using modules and plugins, which we will talk about in further slides. And we have delegated proof of stake as consensus algorithm, which I already talked about. It's also scalable and more energy efficient as compared to proof of work. So Lisk Core is the application which is created using Lisk SDK. And this also allows JavaScript developers to simply use this SDK to create their own blockchain application similar to Lisk Core. So what is Lisk SDK? So Lisk SDK is a set of libraries. There are sub-products within the Lisk SDK. So Lisk Commander is a CLI tool, which is kind of an entry point for any developer. You can simply install Lisk Commander, type in Lisk init, which will create the application, bootstrap your application. You can add your custom logic, like on-chain logic or off-chain logic using Lisk Commander. So it is like a utility tool for the developers on the CLI. And the application is powered by Lisk Framework Library. And Lisk Framework Library is defining the architecture of the application. And Lisk Framework Library, it uses Lisk elements, which is a set of independent libraries which are aimed to solve certain blockchain logic. And these libraries can be used independently in your projects as well. And this application will be running on top of Node.js runtime. So a little bit about architecture, what we have in Lisk Framework. So broadly dividing, like there is off-chain logic, there is on-chain logic. And off-chain logic is maintained and managed by a controller. And users can simply add their off-chain logic using plugins. And on the right-hand side, we have on-chain logic, which is managed by a node, along with the common blockchain logic, which also includes BFT and other things. You can also add your on-chain logic using modules. So users can write their custom logic on-chain logic using modules. And we'll see that in the coming slides. So the question comes, what is on-chain logic? So the logic that lives in the blockchain, for example, token transfers, or if you want to do block validations. And whatever you are saving in the blockchain state, you can mutate it only through blockchain blocks and transactions. And this is the logic which is handled by modules. And the off-chain logic is something which is acting as an added feature to the application. And it's optional. You don't have to run it. Your application can run standalone. And also, it's not part of any blockchain protocol. And this is handled in plugins. So talking a bit about modules. So modules are, as I mentioned, it's responsible for on-chain state mutation logic. It's fully customizable. You can we also have some default modules, and you can take inspiration from that, and also you can write your own custom module. You can also extend the existing module to and give another module ID, and you can reuse it as well. So it's easy to plug and play in this type of blockchain architecture. And also, you can write logic at every block lifecycle hook using modules. So you have access to, for example, you have begin block or after block execution, or before transaction execution, after transaction execution, etc. We ship some default modules along with Lisk SDK, and these are the modules which are also powering Lisk Core right now. So token module is handling all the token transfer related logic. Sequence module defines the sequence of transactions to avoid double spending. Keys module is for handling signatures, multi-signature group, etc. And dpos module is defining the delegate selection algorithm, also including some commands like registering delegate. And now talking about plugins, which is the off-chain logic. So this, like I said, its plugins are optional to run. And to have a better performance, we have the ability to also run it in the child processes. All you have to do is to configure in your config file. And these are accessible through actions and events for the external systems. Some of the default plugins which we have included with the SDK is to improve the developer's productivity. So when you are testing out your blockchain application, it's a bit hard to see what's going on in your node. And for that, we want, okay, there are some tools to help a developer. For example, dashboard plugin is a UI application where you can monitor network, like you can see recent blocks, transactions, and also you can interact with your node by actions and events. Then we have Forger plugin, which is mostly for delegates who are forging, and it is used by them for monitoring purpose and also see some forging activities. Report misbehavior plugin, it checks for any if there is some violation in BFT properties and triggers a report misbehavior transaction automatically. And finally, the monitor plugin is more related to network statistics, how many nodes you are connected to, etc. And this is mostly for monitoring purposes. So you can see, like overall, it improves the overall developer's productivity, especially when someone is developing a blockchain application. Yeah, so the question also comes like, where are smart contracts? And now, like whatever we do with smart contracts or in a smart contract, you can also do with Lisk modules. And there are differences. So for example, Lisk, so modules in Lisk SDK is the logic that is not saved in the blockchain state, but actually on each client. So you have less DB size in this sense. Also, on the other hand, smart contracts, the logic is compiled and stored on the blockchain state itself. There's more governance when you are working with modules because you have your own blockchain application. That means you have your own governance in your chain, and you're relying very less on the governance of the main chain. Whereas in the smart contract, the contract is running on the same chain, so it's also following the governance of the main chain. So since there's no smart contract in module development, that's why there is no virtual machine, whereas in smart contract, you require this virtual machine. In terms of scalability, since these modules are running in their own blockchain application, you have your own network, it means that it's more scalable. Not everything is running on one chain, whereas the smart contract, they share resources in the same chain. But yeah, just to point out, like the module development and smart contract development can be suited to different needs. So for example, if you want to have more heavyweight blockchain application, probably you will like to use modules where you can run it in your own chain and network. And like smart contract is something where you quickly want to get started with something and you have a lightweight application. To overall improve the productivity of a developer while developing this blockchain application, we have some dev tools, which I also talked about a bit in the plugins. And some of the features of these dev tools are to kickstart development. We have application bootstrapping. We have dashboard plugin for monitoring the node, also interact with the node. We have faucet plugin, which is helpful when you want to allocate funds for testing in the network with the users. We have testing utilities, which helps you for better code maintainability. And also for CLI lovers, if they want to run all the functions on the CLI, we have Lisk console command where you can basically run all the functions which are exposed from Lisk elements library. So we will go one by one in each of these dev tools. So the first is Lisk Commander, which is a CLI tool which is used for rapid creation of blockchain application. You can create configs, you can create Genesis block very quickly, you can generate code skeletons for your custom module, for your plugins and assets. If you want to add like on-chain logic, probably you will generate a custom module. If off-chain logic, then probably you'll add plugins. And just to show like how it looks like, so you basically write Lisk init, it will go through some questionnaire, you add that information, and your application is up and running. The only thing is now that you start adding logic for your use case. So in order to, let's say now add some logic for on-chain, you will use this Lisk generate :module, and you will create your own module with the name and ID. And if you want to add off-chain logic, you will generate a plugin with some details, like plugin name. And basically, this will create the skeleton for all the code and the hooks. All you need to do is go in the file and write your logic for that particular hook. Or if you have any transaction type which you want to define, you can generate the asset, and there you can define these params will be coming from the transaction, and this is how it will run in the logic. So it makes it pretty easy, and also this it also generates the test files. The next thing is you can also create a Genesis block. Pretty easy. You can just give some answers, configure, and the Genesis block will be created according to your needs. And there are a lot of commands in Lisk Commander. I will suggest that probably try it out. Go to npm and install, and when you hit Lisk, you will see all this set of commands. And we have like a lot of commands related to managing or interacting with a node, with a running node. Then comes a dashboard plugin, which is a UI tool where you can monitor blocks and transactions. You can generate accounts. You can send transactions. You can call actions, subscribe to events, get node and peer info. So you can see the recent transactions and recent blocks. And also you can see unconfirmed transactions where the transactions which are not yet added to the block but stays in the block, stays in the transaction pool. So you can view that. And it's pretty handy when you are running and testing your blockchain application. It will be nice to have like this kind of UI where you can see whatever is happening with your node. You can easily generate accounts, which comes pretty handy when you're testing in the network. And whatever transaction types you define or which already exist with the default modules, they will be listed here. So even if you define any custom transaction asset, which it will be listed here, all you need to do is you select the transaction type, add the params which it needs, and you just submit. Also, the actions which you define, actions are used for providing information to off-chain services. So all the actions you define for your module will be listed here as well. And you just select, give params if it needs any, and you just submit, and you can see the results. In the later presentation, we have a demo where we can also see the usage of this Explorer. I think then it will make more sense as well. Also, you can subscribe to events. So there are a lot of events happening in the blockchain. You can subscribe to them in this UI as well. You can subscribe to multiple of them as well, for example, block new, or if there's a new transaction, etc. Then we have Faucet plugin. So Faucet plugin is when your blockchain application is ready, and now you want to test it out with real users. So probably you want to send some funds for testing, and this is a very simple UI that could be very handy for a developer. All they need to do is just provide the address of the user, and it will send the LSK tokens or any native token to them. Then we have Lisk console command, which I already mentioned before. It's for the CLI lovers who want to run all the functions on the CLI. So all you need to do is write Lisk console, and then all the Lisk element functions will be available on the console. And for example, if you want to run some cryptography function, you just write cryptography.hash or any other function that it has in the Lisk elements library. And then finally, application testing. So it's a bit hard to test your blockchain application, and we also face this kind of issue while developing Lisk SDK. For that, we thought, okay, why not to expose these testing utilities like fixtures, mocks, etc. And so when you are writing your blockchain application, you can simply test out your application by including these testing utilities. For example, getting application environment for your functional testing, or block processing environment for integration testing, etc. And this ensures the quality projects are coming into Lisk ecosystem, which are thoroughly tested. So this was all about Lisk SDK and also the dev tools it provides and what's coming new. So briefly, I want to talk about what is coming in the near future. So currently, we are in Sapphire phase. We have passed all these phases, and we are approaching Diamond phase. And recently, we have released Lisk SDK version 6, alpha version, which is a great milestone and great achievement because it includes very big objectives. For example, Lisk interoperability solution, as well as there are a lot of other objectives that is included in this version. For example, we have drastically improved SDK performance as well with this version. And yeah, there are a lot of objectives that is included or bundled in this version. Best is to check our GitHub repo if you want to dig deeper in these objectives. And if you want to know more about these upcoming features in version 6, which includes the interoperability solution, I will suggest you to also join us in WeAreDevelopers, a workshop which is happening on 15th from 2 p.m. And also there we will have a demo as well with the SDK version 5.2. So yeah, let's start building. Thanks a lot. So if you have any questions, please ask. And also, if you want to check out our GitHub repository, here's the link. Also, you can reach out to us on Discord. There's a very active community out there. And we have a dev forum where a lot of dev-related discussions are happening. And you can simply install, you can also install Lisk SDK using this NPM. Yeah, thanks a lot. Yeah. Yeah, you want to ask any question?
Yeah. Every application is its own blockchain. Or is there, can you explain, is there a public one also, or how do they interoperate?
Yeah, okay.
You said every application has its own blockchain?
Yeah.
Right.
So,
so
whatever custom module you are writing, you can have it in your own blockchain application that will have its own network. And then you can validate or whatever your change state is with the other chains in the network using the main chain. So all you need to do is to certify, like this is coming from the interoperability solution, but you can, basically run your own modules in your own network.
Is this on? Yeah, it's on. But I don't have to, right? I can also put it on the main chain or not?
No, you cannot run in the main chain. Yeah.
Okay.
So it's whatever the modules exist in the main chain will just stay in the main chain, and probably like if it will be added, then it will be a hard fork.
Okay, thank you.
Yeah.
Thanks. If I want to write a blockchain app, should I do it in TypeScript or can I choose another language?
Currently, we support TypeScript, but probably in the future, like there could be any other client as well. But right now, our motto is to let developers write their blockchain application using JavaScript or TypeScript.
Thanks.
Yeah, so if you cannot run on the main chain, I do have to allocate all the resources myself to have all the nodes and validators. So there is no way to use like a decentralized
Yeah,
approach
like you can. So I mentioned in one of the slides, like so it depends like what kind of use case you have. Like if you have a heavyweight application which requires a lot of processing, also a lot of state information which you want to store in the blockchain, probably you will like to have your own blockchain network. And people can trust that network by by following the interoperability protocol. So you have to certify whatever state you are changing in your chain with the main chain. So the state stays in your own blockchain network, but not in the main chain. So, but you still are connected with other chains.
Okay. And does Lisk also interoperates with other blockchains?
That will be coming in diamond phase. I should have mentioned that actually. But yeah, there are other things which are coming in diamond phase, but in this current phase, it's more about interoperability within the ecosystem, within the chains.
Okay, thank you.
Any other questions? No? Yeah, sure.
Sorry for hugging the microphone. How do I generate random numbers on the Lisk blockchain? You know what I mean? Like it's a tough question. Imagine I have a game and I want it to be random. Okay, so how would you solve that?
Yeah, I mean, it's a tricky question. It's a
I
problem in
know, I
blockchain. We have this consensus protocol, delegated proof of stake, and so there are some delegates which are chosen. There are 101 active delegates, and there are 2 standby delegates which are chosen randomly every round. So we have that randomization as well that you can use probably in your game, but yeah, that needs to be checked with the research.
But anyone can run such a validator, right?
Yeah, I think so.
Okay, and then can yeah. No, it's tricky. Yeah. So anyway, I just
Yeah.
I thought maybe you have some magic solution because you already have so many cool solutions that you might have something for randomness. I would love that, by the way.
Yeah, probably you have to check out this standby delegate selection.
Yeah.
I think there
Okay.
you can find some answers. Yeah.
Thanks. Okay. And who's running the code for that? I mean, can it be manipulated? That's my question. Okay. Cool. Okay. Thank you. That's what I was hoping for.
Okay, cool. Okay, thanks everyone. Yeah.
Very nice.
Nice. Thank you, Ishan, for giving us the presentation and introduction to the Lisk SDK. And as for now, we would move on to the next one, which is understanding a bit better and actually a small demo on how to build your own blockchain application with the Lisk SDK. And I would like to welcome Mona on stage for this. Thank you.
Yeah,
Oh, wait, sorry.
yeah, it's us both actually.
It's actually both. Yeah, so yeah, we just introduced Lisk and Lisk SDK. It will make more sense like if we show it with a demo, right? So we want to demonstrate Lisk SDK with a simple Twitter-like application. It's called Lisk Postboard, which is like simple app where users can post their opinion, view posts from others, and interact with the post. Like you can like a post, you can reply a post, etc. Defining all the features, like what you can do in the application is you sign in with your passphrase, you create a post with some character limit, and you follow other accounts, you view posts from other accounts, you create a user list to categorize accounts. You can repost a post similar to retweet, like a post, reply a post. So before you start adding logic to your application, you will bootstrap your application, and then you will define the account schema. Account schema defines how you want to store the state information of your application. So we have this JSON format which you can define for your account schema that will be stored in your blockchain state. And there is a special format, like you can see there is field number type, which is used by our Lisk codec library to serialize deserialized data and store it in bytes format. Similar to that, we have a post schema that needs to be defined with, for example, ID of the post, content of the post, what you write in the post, the date, the author, repost, etc. So once you define all this schema for your module, which is the post board application, the next thing is to define transaction assets. In order to change the state of whatever is stored and for these accounts related to the blockchain, this application, postboard application, you will define different transaction assets. For example, create a post, you will probably define an asset where you can have params like the text for the post, and then when it goes in the transaction asset, you will have this execute function, and there you can generate the unique post ID and the content of the post and also the author and stuff. Like you can write that logic, and we will see that after this short presentation in the demo. The same thing goes with the follow transaction asset, like a transaction asset. So whatever changes the blockchain state, you have to define the transaction for that. And we'll go through all the assets as well in the demo. So once you have defined all these transaction assets that changes the application state, you add it to your module. And this is like roughly how it looks like, but Mona is going to also show it, go through the code as well. And basically you add all the transaction assets over there, and then you set the account schema that how you want to store the account state. And then also you can expose some data from your module for the external services like get post or get latest post. And for demonstration of plugins, we have created a simple user tracker plugin where you can create a user list, delete a user list, get user list by ID, get user list by address. And this is handled and stored off-chain. That means like other nodes can have different implementation of this plugin as well. So, and nothing is stored in the blockchain state. So this is more like an added feature for your blockchain application. So now Mona, who is lead technical writer, she's going to give you a demo, a walk through the code, and yeah, I will hand it over to Mona.
Yeah, thanks a lot, Ishan. Yeah, hello everyone. So yeah, I'm going now to try to show you a little bit live demo how it is to develop a blockchain application and how it runs. Today I will focus mainly on the backend part. So I will show you like how you bootstrap the application and then how the different module and assets are defined then that the application is running. And yeah, as Ishan described, we tried to build like something like a decentralized Twitter, but yeah, very, very simple version of it. So yeah, I don't know if you can already see my laptop, probably not. Would be nice if we could switch to it. Why is it? Is it possible to see the laptop? Ah, okay, now we see it. Okay, cool. There's one thing, my screen always switches back if I do this. I'm not sure why.
It's working, right?
Okay.
Yeah.
So then let's start. If we would want now to start building this application, as Ishan mentioned, there is a very helpful tool that you can use to bootstrap the application. This is Lisk Commander. If you install it on your CLI, you have the command Lisk. If you just type Lisk, then you basically see also help, like which are the commands which are available in Lisk Commander. And the most important command for us at the moment is init, because it will bootstrap the whole application basically. And if you would want to do that, I won't completely do it now because I have already done it, but theoretically it's just Lisk init. Then you hit enter, and then it will ask you a few questions that you need to answer. I won't do it now. But if you have done it, it will just completely create all the necessary files for you to have like a very default blockchain application with all the default modules already installed that you can then already run. But of course, it has no custom business logic, so it's a little bit boring at the moment. So how it will look like is basically you can see here, so this is the folder where we have run Lisk init inside. And the most important folders are first the bin folder. There's just stored the script that is running also a command line interface. Every blockchain application also has its own command line interface, which is just making it very easy to interact with the application through the command line. Do I need to make it bigger maybe a little bit, or is it like good? Yeah, I hope it's readable. So this is the bin folder. Then we have the, sorry, I'm in the wrong folder now. Here. Okay, the bin folder is where you have the script for the CLI. The config is just a folder where you have the config for the blockchain application. So you have a lot of different configurations that you can directly just configure there. And also important, what was already mentioned, is the Genesis block. This is the block that you define as a developer because it's the first block in the blockchain. This is also why it's called Genesis block. And there are also a lot of interesting things that you can define, like the Genesis delegates or some Genesis accounts who have already some money attached to the account, and many other interesting things. but yeah, we're not going into detail right now. Another thing that was already mentioned by Ishan is the test folder, which is also automatically generated, which is also when you create modules and assets, it will also create skeletons for the unit tests for the assets and the module. So right now they are not written anything, but yeah, once you want to really test your application, if it behaves like you expected, then you have here the place basically to write your tests. And now the most important folder is the source folder. Here when you open, you see basically two folders are created. One is called app, one is commands. Commands, again, is just for the command line interface. So if you want to add more comments to your command line interface of your blockchain application, or you want to exchange or change the existing commands, then you do it here. But for now, we won't touch the commands because the default commands are already pretty nice. So we open the app. And this is basically now the place where all the logic for your blockchain application actually sits. And as you see, also here we have two folders, modules and plugins. And yeah, also the app file, which is just basically bringing everything together and starting the app. And also the modules TS file, where basically all the modules are registered. For our application, we now have, beside of the default modules, which are already installed, only this one new module, which is the post module. And the same we also have for plugins. There we have basically our own written plugin, the user tracker plugin, and also we have one of the default plugins that we are installing here and using in the application, just to show you also in the dashboard how it looks like. Yeah, so if you have now run it with Lisk init and all these files have been created, you can now also generate the plugin again with Lisk Commander, because we have this Lisk generate command here. As you see, there are three different things that you can generate: assets, modules, and plugins. Yeah, we can start first with the module that we want to create. So it's basically, Lisk generate module. And now you also need some little parameters. If you are not sure what they are, you can always type -- help, and it will show you the information. So actually the command expects module name and module ID to be defined. For our application, this was basically just post as module name and 1000 as module ID. The only thing that you need to think about here is that they are unique, and also the module ID, it needs to be minimum 1000. So everything above 1000 is valid. Yeah, when you now type enter, it will automatically also create skeletons for the module inside of your existing application. And yeah, this then basically looks like this. It will create a new folder. And inside the folder, it will create this file post module. And inside the post module, we can now define all the important parameters. First, we can see here again the name of the module and the ID of the module. They are already predefined because we auto-generated them and already set there the name and the ID. The other things we need now to define, like for example the account schema. This is like a schema you need to provide because every module can introduce new properties for user accounts. Like for example for these social media app now, we want not only, for example, balance and address in the user account, we also want posts and likes and follows. So these are like new properties that we need to define at this stage. Also, you can see here the transaction assets that are registered here. We will see in detail soon how an asset looks like and how it is generated. And also we have the two actions here defined that we actually need to get the post from the database because it's like a newly defined data structure. So we define a new method that also from externally you can query these posts and get a post by ID basically. And a second one, which is just getting an array of all the latest posts that have been sent to the network. Yeah, this is more or less the post module. So if we now want to define our first asset, which is then used to create a new transaction type, we can go back here and see again the help for the create generate asset command. So here you see now it needs a module name, an asset name, and an asset ID. This is the case because every asset always belongs to a particular module. In our case here, the post module. So we would type generate asset, then post. Then we have to think of an asset ID, for example, create post, and also an asset ID, which can start with 0 actually. So there you don't need 1000, because the ID of an asset is always bound to the module. So I won't do this as well, because I have already done this to create the example application. And if you look at now at one of the assets, here, for example, the create post asset, which will then, in the end, create a new post based on the data you send to the application. And here you always see, again, the name and the ID, which we predefined. Also, you have a schema here. A schema here is the data that is expected to be included in the transaction for the business logic to work. So we can also quickly look at the schema. It is defined in a separate file called schemas. And here you see, like Ishan showed, is this JSON format. And for create post, we actually need only one property, and it's the message itself that the user wants to send. Yeah, data type is string, and additionally, we can already also define certain validations inside of the schema. Then we don't need to validate it again in the asset. So here we basically said a message needs to be at least 3 characters long and maximum 256. So if we go back to the asset, so what we have done now is name, ID, and schema. What we are missing now, what to do with the data that we receive. So yeah, what we want to do is actually with the message to create a new post in the database. So the first thing what we are doing is in the apply method, getting the sender. So for this we use a state store. Inside of the apply method you have access to the state store. This is like, yeah, very important data structure because you can get and set data in the database with the state store. So at the moment we want to get the account from the sender who sends these posts. And second, we want to create a unique ID for the post so we can send it in the database. Which we do here. And then the third step is already creating the post object. This is also defined as a schema. So I think if we go here, yeah, we can also see here the schema defined. So the database expects these 4 required properties: ID, content, date, and author. But every post also has replies and reposts and likes, of course. So this is kind of everything that is part of one post object. And now go back here. Yeah, here you can also see all the different properties, and we basically set the ID to the unique post ID we created, the content to the message of the transaction, Date, we just use the current time, and as author, the author address right now. And as it's a new post, there are no replies, posts, and likes yet. And the rest is just using the state store again to set now as save data in the database. So we save the post under the unique ID of the post. We also add the post ID to an array of all posts, so it's actually findable. If you query these lists, then you will get basically a list of all IDs of all posts that were created. And last but not least, we are also saving the post ID in the sender account. So yeah, as you know, we also created here in the post module a schema for the account. We can also quickly look at it. So these are the additional account properties that are added to an account when you install the post module. So each account has following, followers, the posts that this account created, the replies that this account made, and also likes. So this is all also stored in the user account if a user likes something or replies to something. Okay, this is now more or less how the code looks. Now we can also try to run it and see how it looks in the dashboard, just making some example transactions. So to run it, we use this bin run, and then if you just run bin run, you also start the CLI without any commands. It just displays a help again, like what are the commands available in the blockchain application. Yeah, for us at the moment only interesting is start, because yeah, we just want to start the application. So we do bin run start, and we also use some flags to enable API WebSocket. Yeah, and then basically you see a lot of console logs where the blockchain application is bootstrapping. Right now for the example application, we have reduced the delegates a lot. Default are 103, and yeah, we have now only 6, so it's easier. Also what I can mention, this is like a development environment, so this is not like a decentralized network yet. It's just one node running on my computer, but it's already a full blockchain application, so you could decentralize it and like every delegate actually running on an own node, and then yeah, have a decentralized network. But of course for development purposes it's better to have everything on one machine. And here you can see new logs are getting added every 10 seconds. These are the new blocks that are added to the blockchain. So here you can also see, okay, it's already doing something. And because we have added the dashboard plugin and registered it, we can now go to localhost 4005, and this is the Lisk dashboard that we can access. And here we have now the opportunity to yeah, conveniently send and send transactions and call actions. So if you click the drop-down, here you see also from all the standard modules the transaction that they offer. And below you can also see it already also lists the transactions that we created newly, like from the post module. So we can select create post. And for a post, we actually only require a message. So we could send something like this, maybe. Greetings from WeAreDevelopers 2022 in Berlin. And of course, what we are needing now is a passphrase. And the good thing is, in our Genesis blog, we created some Genesis accounts with already some funds inside. So I can just use one of the passphrases from the Genesis account, enter it here, and now hopefully, yeah, success. So the transaction was accepted. You see it in the UI, but also when you look here on the logs, you can see a transaction was added to the pool, and then in the next log, a new block was added to the chain, and also the transaction was included. So here we also see, okay, it has worked. And of course, now we want to see maybe the post also, we want to get the post back so that we see, okay, it's really created. So we can call the action get latest posts. It should give us a list of all the posts that are available. So there's only one at the moment with this ID. It's very long and ugly, but at least it's unique. So now we could also get the post. For this, I need to define the ID. Like this, and it should hopefully get it. Yes, now we can see, okay, the author. This is our address, basically, of the author, our message that we have just sent, the current date as Unix timestamp, the ID of the post, and now, because no one has liked or replied or reposted it yet, these arrays are still empty. And now you could, of course, also repost it, maybe a different person. One moment. So if the second person now wants to repost, it's very simple. You would just use their passphrase. And here for reposting, I think in the schema we need the post ID, not more. So we want to repost this particular post. And now you can also see again here, transaction added to pool. And transaction included in block. And once you get the post, you will also see this account has actually reposted this particular post. And same actually for like is pretty similar. You also need just a post ID. You can like the post, and it will also be added to the array. You could reply. Maybe also with the same user, just for simplicity. For reply, you don't only need the post ID, you also need actually the content of the reply, which could be something like greetings to you too. I don't know, something like this. And then you send it again. And you can always check here also in the logs if it's already included in a block. So it seems like it's already included. It's a very small window, unfortunately, but I hope you can see. So here's now a reply. And reply is as an object directly added to the post. And has also always an author, a date, and content. For simplicity, we didn't make options that you can also like replies or reply to replies. So it's a very simple version of Twitter at the moment. But I think that's more or less it that I can show you. Unless you have any further questions. Here's also follow. Follow is basically, one moment, we can, for example, use this account here and say we want to follow it. Then we would put something like this, send the transaction, and I think we have one script that we can use to get the account, because as an alternative, if you don't want to use the dashboard, you can also use write your own scripts basically Like for example, this short script, which is just getting the account data. You can also then run it in the command line. Okay, yeah, this is the account that created one post, and you can also see it's saved here. And then also from all the other modules, there are certain properties that are also saved in this account. Yeah, and this is the way you can check it. Yeah, for the UI, I think it's even more exciting if you can also see how it looks in the UI, but yeah, today we don't have time to present it. If you're interested in it, there will be another presentation on WeAreDevelopers where we go into detail about yeah, backend, but also front end a little bit more, so you can see how it works in the UI. But yeah, more or less that's it from my side. Thank you. Yeah. Any questions so far, or all good?
1, 2. Does it work? Yeah. Can I have a question again? I'm sorry. You guys and girls should have questions also. I have very cool, very cool. You mentioned a database. Now it works. You mentioned a database. I would like to know, is it a decentralized database? Where is the data stored? How is it safe? You know what I'm saying?
Yeah, the database with database, I mean in this context blockchain actually. So yeah, the blockchain is also kind of a database. Actually, we use a key value store where we save it. But yeah, everything that is on-chain is also part of the blockchain. For the plugins, you can also store stuff in the data, in the key value store. But this is off-chain still, so it's not part of the blockchain.
Okay, so it's stored as state on the blockchain and it's tamper-proof and it has a history, right?
Exactly.
Oh, okay, thank you.
Okay. Any more questions?
Also to add on to that, so whatever data structure you define for your module can only be able to update those things, only those properties which you defined in the application state. For everything else, you can interact with the other modules using what we call reducers. It's like an API interface between modules. And if you, for example, make a token transfer, you can just do it in your own module, but you have to call this reducer API of the other module. So this is how you can change the state, but also it is secured enough, like you don't change the state of other modules accidentally.
Yeah.
Yeah, cool. Thank you very much,
Okay.
Mona and Ishan.
Thank you.
Great. Super thanks for this. It was really cool to see what you could do with the Lisk SDK in 30 minutes. And we actually have a 30 minutes break now, so you could either start developing with the Lisk SDK in 30 minutes, or you can grab something to eat. For you with the live stream, we will be back in 30 minutes with Michael Ionita talking about smart contract architecture.
I can
Thank you.
shipping.
Well done. I didn't understand
Thank you.
anything, but well
Hello, hello. Welcome back, everybody. I hope you had a nice break. We're just going to continue a bit with our schedule. And today we brought our guest speaker, Michael Ionita, which has been working within tech for over 18 years. And also has his YouTube channel where he's demystifying tech, blockchain, and NFTs. And we have him here today to talk about smart contract architecture. So I would like to welcome on stage Michael Ionita.
Thank you very much. I hope I'm holding the microphone okay for the audio team. Yes, thank you, cool. Thumbs up, it's nice. Thank you for putting the light so that it's totally in my eyes. I love it. I'm just kidding. So thanks for the nice introduction. Yes, indeed, I did a lot of coding, a lot of hiring of devs, running teams. But at some point, I thought like, I don't know, I think I have to learn about the blockchain. And so I did that, and I thought, okay, let's teach some people about it on YouTube because I can reach more people at once. So whatever. So what I learned, what you're going to hear today is what I learned in my journey of doing a lot of mistakes, messing it up on the blockchain. I am not familiar with Lisk or magic they're doing. Yes. So what I will tell you, you will see, what I will tell you is more the blockchains that you might be familiar with because that's what I know. Yes. So it's not Lisk, this one. It's more like a broader picture, how to think about smart contracts. So whatever, I founded my own company, CTO, blah, blah, blah. The only thing I wanted you to understand here is that I'm a tech guy, okay? So that's important. And if you want to check me out on Twitter, I would appreciate at Mizi. Okay, so I also have a YouTube channel, you know that already, whatever. So this is the outline of today. So we're going to talk about smart contract lifecycle, state and architecture, and some code samples. So you will see some code, yes? I think you will see, I hope you can read it better than before. I think so. And so what I will tell you here is very much EVM specific, because that's what I know, that's what I do, right? So if you don't know EVM, that's the Ethereum virtual machine, which is obviously used by Ethereum, but it's also used by Avalanche, Polygon, and some others that basically support it. So that's Solidity programming language. Anyone familiar? Okay, a few people, cool. By the way, if you have any questions in the during the runtime of my presentation, yes, that's a nerdy joke, then just ask in the middle, right? Okay, so a life cycle of a smart contract, it's like this, right? You code it, you deploy it, you configure it, and that's it. You can't change the code anymore, right? Who knows what I'm talking about? All right. So okay, so it's immutable, right? I want to make you feel bad right now. It's because I cannot change my code anymore. What the hell? So if you want to add new features, nah, right? If you want to fix a bug, not possible. If you want to improve gas fees by changing your function to be more efficient, you can't do that. Or can you? So I want to talk about one way how you can architecture your smart contracts so that you can actually still make changes to your application. Sounds like it makes sense, hopefully, right? All right, because if you can't do that, then basically you have to get it perfect from the first go, which is very hard, okay? So how do you feel about you cannot change your code anymore after it's deployed? Is that normal? No, it's a pain in the butt, right? Because you're used to just deploy some bugs and fix them later, right? That's how we do it. No. So obviously that's pretty bad. But it also has some obviously has a lot of benefits because once you have the code out there, people can trust that it's always doing the same thing. And that's great. And that's exactly why the blockchain makes a lot of sense. Now, we have to talk about smart contract state because that's the actual problem that prevents us from changing code, right? Because I don't know if you know NFT smart contracts. Anyone wrote them? Okay. So it stores who owns which NFT, right? And now if you want to add a function in there, it doesn't work. If you deploy another contract, then all your ownership information is in the old one. Now you're fucked, right? Because you have to transfer the data over. And even if you transfer the data over, every OpenSea platform already indexed the old one. So you're screwed. Yeah? So you have to make sure the state stays where it is and your features are somewhere else, basically. So what is the blockchain all about? Okay, I will not ask you, I just go, in this case, it's storing ownership, okay? So I just want to make sure that, simplifying things. So the blockchain is all about storing ownership and, of course, keeping track of how ownership has changed from me to you and from you to this guy and so on. So you can transfer ownership of coins, right, of NFTs, but basically that's it, right? It's not like you can run any kind of smart algorithm on the blockchain. I mean, yeah, it does simple mathematics, yes, but it doesn't, it's not, you know, it's not the main use case. The use case is you can own your own things, right? And that's why NFTs are so important. And that's why also, once you deploy a smart contract that stores ownership of coins or NFTs, that ownership is permanent, right? Unless, of course, it gets transferred by the user himself or herself. So you cannot just mess around and change that code, right? But what if you're creating a game or any kind of stuff that has new features in the future, you talk to the community, they come up with new ideas, right? And you want to put it in there, how the hell, right? How does it work? And I want to prevent you from some traps that I ran into, and so there you go. So the ownership information is obviously the state that we have to preserve. So now the question is, oops, I'm trying to go back. I will manage. Give me, I don't know. When, yeah. Can I go one slide previous, like one up? Yeah, I know, but it doesn't work. No, there we go. Right. Okay, cool. So if you look at this, ooh, there is even a laser pointer. Damn, that's amazing. Okay, so if you look at this, basically you have the user wallet generating some transaction on the NFT contract, and obviously it will store the state of whatever you've done here. And if you have a contract for a coin, which is ERC20, by the way, if you care, then it will store the state here. And that's cool, but what if you architecture your smart contracts like this? Because, yeah, I mean, what I wanted to say before also is that if you want to add any functions here, you won't be able to because the code is already deployed, and we're going to talk upgradable contracts at the end, okay? Don't worry. Or if you want to change some functions here, it's too late, you know? But what if you deploy something called a coordinator contract? You can call it main contracts, whatever, yeah? Coordinator, it does no state at all. It doesn't store anything on the blockchain. It just has functions that get data from other smart contracts, calculate something, you know, and comes up with a state, with a result, and then write it into these, like changing ownership or whatever you have in those contracts. So basically, instead of going directly to these contracts, you're going here to this one, and you make sure that these contracts cannot be called by the user themselves. I mean, only for tiny, you know, functions, but for the most part, it can't be. Instead, the coordinator contract will call them, and there is a way in EVM at least, I think in any blockchain language, where you can say who can actually call which function. You can give addresses on the blockchain, say this address can call, this address cannot call, right? And this, you call it admin or whatever. So in this case, what you can do here is you can add a lot of functions here. You can upgrade this. You can actually redeploy this contract, right? So you can have multiple versions of this because it doesn't have any state. So you come up with a new feature. You just add it. You deploy a new contract. You tell this contract and this contract that this is the new coordinator address, and that's cool, right? It's very easy. It takes you 5 minutes. So this way, you don't change those because they only store ownership information, which what we talked about, that's what the blockchain is really about. And any kind of calculations and features and staking and, I don't know, not storing the staking, but calculating the rewards, right, for staking. How much do you get, right? It can be here. And if you want to change the formula of calculating the stake reward, you can, right? Because you just deploy a new version of this, you tell those contracts who is the new thing, you're good, right? So I did this in production, obviously, it works, okay? So this is really cool because you can always go to your team and you can say, yeah, sure, we can upgrade that, we can change that, we can improve that because, right? Obviously, if you fuck up this or this, that's it, right? But that's clear, I mean, it's obvious, right? But that's easy, you know, because now you're making this very simple. I will show you some code. Like it's just a few lines of code for storing ownership, and that's it. The simplest contract, you can't fuck it up, really. So little code, you know? And even less code here, I guess, in the coin. But this one can be bigger, right? Because it has a lot of logic in there, but no state, okay? It doesn't store anything on-chain because, you know, then you're fucked again. If you want to store state, you can, of course, deploy another contract somewhere else just for storing some additional data, right? And this contract will then go there and come back and decide what to do. And so I think this is a good architecture, right? And also, we're going to talk about why there are some other benefits that are more like religious benefits from, loving immutability and stuff like this. So what did I want to say with this slide? Yeah, I wanted to just show you that if you wanted to redeploy this one, you're pretty screwed, but I think you get the idea. What else? Yes, here I wanted to show you that basically, yes, like if you wanna, if your NFT contract that you have originally deployed is not good enough, and you're like, I want to store some more state, some additional variable or a map or something, and I just forgot to add it, right? Now, I cannot add it here because I'm not allowed to create state. So I can deploy an add-on contract. It's its own thing, okay? And you basically just store it there, and you keep it simple. Keep the state very simple, okay? And again, you can coordinate it with this, right? So you read from it. So the user makes a request. And that's actually you, right? You're deploying this contract. You're telling this contract who is the one that is allowed to call this. And you basically just, whenever some user wants to interact with your application, with your dApp, and it has to go to chain, you basically, this one reads and does everything it has to do, stores stuff, and so on. Only make sure that this can only be called for writing by this guy. Because the user should not be allowed, right? Only you can. That's obviously important. But that's very easy. You can store a map on the chain and just say the addresses that are allowed. How could? When rich? Yes, please.
Is there a way to avoid paying more fees if you need to pay?
I mean, yeah, I know what you mean. Those changes, telling them which address is allowed to call, that's what you mean?
No. You need to update many states. I understand you have to pay more fees to do those transactions.
Yes, but I mean, you would pay it anyway. Even if it's in the same contract, you would still have to update the state, right? So it doesn't really matter. A tiny bit more. It's a little bit. It's not too much. It's not like game-changing more. You know what I mean? Like, but yes, a little bit.
But is there like optimization that you can do to make everything combo in one transaction?
Sorry. Yeah.
Okay,
Can you say again?
Just so as I understood, the more contract you put there, the more state you need to maintain. So if you want to update, if you want to update more states, it means that you need to pay more transaction fees to keep those in sync. So my question would be if there is any optimization you could do to maybe feed them all in one call.
I mean, not with this architecture. And so there are two approaches to this, and I'm just basically selling this approach because I think it's cool. But there is another one where you can actually, it's called upgradable contracts, where you can actually inject code into existing contracts. But it's not my favorite method, right? It's okay, it's there, right? You can do it, but we can talk about, actually I have a slide for discussing that as well, because of course. But that has some downsides also. I mean, everything has a downside. I think if you have more features and you need to change more state, your application is more complex. So physics demands you put more energy, So you have to pay more money. But it's not like gonna cost you the world, like if you do it like this. It's, yeah. Also, I should mention that, sure, you can do this on Ethereum also and stuff, but usually so what I'm talking about here is usually bigger games or bigger dApps, which have my 5, 10, 20 contracts, which is actually what I was working on. Those are usually not on Ethereum because it's, like they have many transactions per user per day, so it's too expensive. So those things will run on Avalanche, on Polygon, something like this. Where it doesn't really matter, too much. But if you do it on Ethereum, you can. And usually on Ethereum, you try to keep it mega simple, right? So that people don't pay too much gas. It's not made for that, right? We can talk about that also. I love it. But Ethereum is just made for other things. So yes, it will cost a tiny bit more gas, but I think it's not really game-changing. So how does the code look like? So basically, hope you can see that. So basically, this is a smart contract for an NFT. What is that? That is for that's basically a coordinator contract. So here I wanted to show you that. So that's the coordinator, the green one in the middle that you saw in the diagram, and this one is an ERC20 token, just a coin, right? A fungible thing. And now there is an interface to this coin so that this contract actually knows which functions can be called here, because otherwise it doesn't have any clue, right? So there is an interface just explaining that there are some functions. One is called mint, one is called burn, one is called add admin, whatever. And when the user calls, here's some useful function, right? When the user calls this coordinator contract, then this will actually invoke another contract, right? And call that other thing, right? So it will call mint from the coin contract and will send the parameters. And this is actually the function it will call just in this other contract. So basically, just going from one contract to another. And that's also interoperability, right? Because on the blockchain, they are all the same code base. You basically can interact with any other contract that gives you permission. And so this is what you're doing here. Ooh, that's much better. Thank you. Something happened with the contrast or with the brightness. And in order to set up this thing, I don't know if this is Solidity, right? I know it's not Node.js or something, but basically you have a function called setContracts where you give the address of the already deployed coin contract, and then you instantiate the interface with the address of this other contract. It's a variable, and it's called coin contract, I called it in this case. And that's how you call it. And you just basically use the function that is in this other contract that is defined by the interface. So long story short, you can call any other contract like this. And this is how you do it, right? You keep this super simple. So that's the whole code for a coin. Right? There's nothing much more you need, okay? That's it. But this one can be massive, right? I mean, as long as there's some limit on how much code you can put on EVM and whatever, you get the idea, okay? But here you can put a lot of features. So if you come up with new ideas, you just add them here, and you just call this thing, get information, write information, whatever, right? And you're cool, and you can do a lot of creative coding there. Okay, so this just for completeness reasons, the interface I was talking about, this is the interface, just explaining that the coin contract has these functions and mint and burn, just so you have seen this. So just so you have seen an interface, right? So what are the benefits? Okay. So what's in it for me, right? For you. So I think the benefit of doing it like this, compared to upgradable contracts, which again we can still talk about. Whoever has knowledge about this, you might have. Okay, very good. We can have a Q&A or a quick discussion so you get the full picture, because I think it's fair. So I really like this approach of splitting state from non-state, right? And trying to keep state contracts super small so you can't fuck it up, and have stateless contracts that you can obviously redeploy 50 million times. One of the benefits is that it respects immutability, all right? So if I deploy a code, right, I can't change it, and everyone that is a user of that application can be sure that the code will look like this all the time. I cannot just rug them by changing the code by injecting code into the contract. It's not my favorite thing to do, yes? And also it's very hard to figure out how was the code looking before, what was it doing, and what the hell. So I think this is very important for security reasons, for trust reasons. So basically, we deploy only once. If we messed up that deployment, we should do it again and not even run the application, but it preserves immutability, which is the whole point of the blockchain. Now, if the community let's say you upgraded, you have deployed this green box, right? This coordinator contract again, like a new version, and the community complains. They don't like it, okay? Like, what the fuck, right? You added something we don't like, okay? Easy. The old one is still there, no? Because it's on the blockchain. So you can just tell the other contracts, okay, cool, we go to the previous version. Easy. And you just point to the previous address of that green box, yes? And you're fine. You can go back easy. So you can respect community vote if they say they don't like the new version. If you do code injection, have fun with that, yeah? So anyway, so we can add new features, right? Like we discussed. You can just redeploy this stateless contract, add new things in there, that's cool. We can improve existing features, obviously only in the stateless one, but that's also cool. And the downside is, because there's always downside, so you can obviously not fix any bugs or so in the stateful contracts, because, yeah, it's over. So those ones should be simple and small and obviously well-tested. So write your tests, please. It's important. So yeah, that's the architecture that I would recommend for bigger projects. And what about upgradable contracts? Sure. But like I kind of mentioned already in my sentences, I think, yeah, it breaks immutability, and it's hard to get back to the previous version unless I'm wrong. And if you fuck it up because you upgraded your contract and made a bug, that's it, right? It's basically hard to get to fix it, right? So now the whole thing is dead. You can't go easily back to the previous version and improve it. So that's something that I brought to you from the field. I worked on a pretty big project with 10 smart contracts working together. And that was a pretty complex project. And this is the architecture that we used over there. And it was, so I can't complain. Yes, it works fine. It worked perfectly fine. So I hope it brought you some value. I want to go to Q&A and have some back and forth with you guys. We still have a little bit of time. We have about 10 minutes, but that's on purpose so we can really have a discussion. I know you're not very active today, but please ask some questions. I will talk to you for sure. And so I hope that helped you. Thank you very much. Questions? Yes, there is a.
Thanks for the nice presentation. I have just a question. How do you guarantee that nobody else can tell your NFT and token contract to update the coordinator contract in some malicious way?
So there is, I left that in the code so that I can answer this question. Here. So there is a function called addAdmin here, and it adds an address into a map. And then there is a modifier called onlyAdmin, and I put it here on the mint function. And maybe I shouldn't put it on the burn, but that's a different topic. I put it on the mint, so onlyAdmin that is in this map, the map is somewhere here, here admins, right? The map is here, so only the addresses in this variable are allowed to actually call this function, which is the, in this case, the coin. And so only this contract can call this function. Right, so that's how I do it.
So you add, when you want to update your coordinator contract, you add your new coordinator contract.
And you remove, so you add a new admin address, the fresh one that you just deployed, and you remove the old one. Because just for security reasons, you remove the old one, right? To be sure,
Yeah, thanks.
Cool.
Makes sense.
Ha! It made sense to put it there. Yes. So I want to talk to you, yes? So give him the microphone, please. Make it.
Thanks a lot. Is this already industry standard, or is it?
I don't actually. That's a good question. I don't know, but that's what I used, and it worked fine. Okay, so project is huge. I don't know if it's industry standard, but that's how I would do it in many cases. Sometimes it makes sense to do upgradable contracts. Maybe when you do a DEX or something, and you don't want to lose people's funds forever. You might have something like this. But yeah, what do you know? Maybe some benefits and downsides of upgradable contracts. Do you have anything you want to share?
Oh, my brain is steaming right now. I have so many ideas, but
yeah. Okay, cool. Did anyone develop upgradable contracts already and upgrade them on chain and stuff? No. How many people are actually developing smart contracts? Are you kidding me? Okay. But this will help you a lot, okay? Like really, if you create something that is bigger than one contract, you will need something like this, okay? So keep in mind, I hope the slides are available somewhere. Yeah, of course, yeah. Okay, because this will really save you a lot of headache, okay? Just the idea of how to structure your smart contracts. Architecture is in general important, okay? You can't ignore this. Okay, but who is actually a full-time developer? Okay, 1, 2, 3, 4, 5, 6, fine, okay, whatever, 7, not many. And what are the other people doing? Because the whole presentation was a lot of code, like before, especially before. So just want to make sure it's valuable for everyone. In any case, keep that in mind. I call it coordinator contract pattern. I don't know, whatever. Right? I'm sure there is a better name in the future for this. But coordinator contract, I think it's fair to call. And like I said, I'm pretty happy with the outcome so far. Of course, if I create some staking contract and I'm stupid enough, let's say, I'm stupid enough to add too many functions to it. Staking, right, where you can lock up your NFT or your coin even, you can lock it up. And then the contract gives you rewards, right? The longer you keep it in, the more rewards you get. Now, you might be tempted to put all this logic of calculating the rewards into the staking contract because it's, you know, separation of concerns, or you put it in the same place, right? But that's bad in this case, because if you want to change the logic of calculation, or you have a bug in there or something, that's it, right? It's over, because all NFTs are locked in that contract, and in the same contract there is a logic on how to calculate rewards. Now, oops. So if you want to change the logic of calculating rewards, that everyone has to unstake and stake again in the new version of the contract. You want to avoid this shit, right? Again, remember, keep stateful contracts very tiny with as little logic as possible. That will solve a lot of issues in the future. So I hope that one you can take with you, and it will solve a lot of, or prevent you from a lot of traps. Yes.
Just one question. So a DAO could be also an admin, and
yeah.
Okay.
I mean, a DAO, I think in a DAO you have to be very careful, because a DAO is community, like, is basically community owned, I would say, right? So, So in a DAO you want to make sure, so in a DAO for sure you don't want an upgradable contract, because everybody will like that, okay, everybody that knows something about coding, they will be like, what the hell, right? They can change code beneath any second. I can't, you know, like I can't be sure that the DAO will be like this forever, right? Right? But it has to, because you can't change the rules, yes? Because otherwise it's unfair. So in a DAO, definitely you want to make sure that you have this pattern, but also you want to make sure that you are able to remove yourself as an admin at some point when everything is working fine for a year or 2 or 3. At some point you want to give up admin rights and give it to the community, and it will stay like this forever. So that gives 100% security to the community that it will work like this, and there is no changes to the rules, right? But why they don't do it in the beginning, most projects, is because they don't know, right? They might have to make changes, but at some point they renounce ownership, right? Or they remove admin, right? And so nobody can change this anymore, and it will stay like this, right? And that's the ultimate goal of these DAOs and these projects, yeah. Aha, that's funny. Actually, you're asking me on purpose, or you know that I do no code also, or? Yeah, I know, yeah. You know, yeah, okay. Yeah, I know, okay. So yes, there are some no-code solutions for that. Basically, so I have a video on my YouTube channel. Go and check it out. It's the same name, you find it, right? And I talk about no-code tools for the blockchain. You can do your own coins by just clicking them together. You can do your own NFTs. Actually pretty good. And you can also do gated content, where people can only watch a video or watch your live stream, or get access only if they have an NFT in their wallet. Okay, well, that's cool, right? So you can have memberships and stuff like this. And there is also a pretty, like the biggest no-code tool is, or the best well-known one, biggest one is Bubble.io, and they have some plugins for MetaMask. So you can click together a pretty complex custom application and have users log in with their wallet. They can call smart contracts, and they, like basically you can create a dApp, right, or Web3, the front end of a dApp, basically with Bubble. You can click together your smart contracts with one of those no-code tools, and there you go. You have a dApp, okay? Maybe it's a simple one, but you can do it. So yeah, thank you for the question. So for whoever didn't raise the hand, when I asked, are you a developer? For you, for the others, might be interesting to look at no-code tools for creating these things, and I have a video about that. So I'm not going to go now into detail, because the video is 15 minutes. Yeah. All right. Other questions? Cool. All good? Yeah. Okay. Cool. With that, thank you very much for listening, and hopefully it brings you value. See you next time.
Nice. Thank you for this, Michael. Super interesting to hear about smart contract. And to move on to our next topic, I think everybody here mentioned blockchain interoperability today. So actually our next activity will be a panel discussion between Lisk and Interchain. So I would like to welcome up Alessandro, Susanna, and Maxime, that will be the moderator of this discussion. Happy to have you on board.
We have Susanna, PhD.
We do. Can everybody hear us fine?
Hello? Yeah.
Hi.
Hi.
Yeah.
Yeah.
Nice. Oh, that's. All right. So, welcome everybody to this panel discussion. Yeah, we're being a bit blinded here, but
Yeah.
I guess that's the point. Okay. So we will talk about the future of interoperability, and I'm very happy to moderate. My name is Maxime Gagnabin, and I'm a research scientist at Lisk. Today with me, we have Susanna Evans, PhD, and Alessandro Riccotone, also PhD. And just to say 2 words about our panelists, Susanna Evans, so PhD in bioprinting from Cambridge, then worked for Zero Knowledge Validator, where it's a company that runs validator for different proof-of-stake networks. That triggered your interest into blockchain communication and inter-blockchain communication. And now you're product lead for IBC at Interchain. Welcome.
Thank you.
And on my right, we have Alessandro Riccotone, PhD in physics from McGill, head of research at Lisk for now almost 3 years. Welcome as well to this place that you know quite well.
Hello.
So,
thank you.
Thank you. So to start off the panel, maybe just a few words to simply explain what is the concept of interoperability. Maybe starting with you, Susanna.
Yeah, so interoperability is about blockchains being able to connect and communicate with each other in a seamless way. So, yeah.
Very good definition. So maybe to build up a little bit on that. So basically, the idea is that we want to validate the state of one chain on another chain to be able to process a state transition on this chain, depending on the state of the other one. So I'm going to repeat chain a lot of times now, but that's kind of the, as you said, the summary of it. Maybe just something that I'd like to say now, because it's going to be useful later on. It's important to make a distinction, I think, between interoperability between homogeneous chains, like you could have in the Lisk ecosystem. What we mean by interoperability, meaning chains that share, the same common consensus rules, maybe the same interoperability protocol, and so on, which is also, in a sense, the case for Cosmos, like chains have to follow the IBC protocol.
Well, I mean, the first use case of IBC is for homogeneous chains that have the same consensus mechanism, but IBC can extend beyond this with different light client implementations or using a solo machine. But I'd say within the Cosmos SDK and Tendermint-based chains, that's like the first live example of the IBC protocol being used, but there are other developments beyond that. So I think the next use case we'll see is with the Beefy light client, which is for substrate-based chains, so that will connect Polkadot and Kusama.
Right.
Yeah.
So very nice, starting with homogeneous chain, but then expanding to more heterogeneous.
Yeah.
And so at the moment, interoperability really is getting a lot of attention. There are many products that try to work on their own solution for interoperability. Would you say that this is a short-term trend, or will we see a more long-term viability for this this topic? Maybe starting with Alessandro.
So as you said, in the industry, the situation is quite diverse. Several players are developing their own solution, which sometimes can be also quite different. So in this sense, interoperability, the story that we always hear is that it's the solution to the scalability problem. You try to go wide, in a sense, right? So you have several chains that can work in parallel and then communicate with each other whenever they need to, right? So in this sense, of course, we need interoperability, and it's not going to be a short trend. But also, just because in the future, we do not know which of these players will be, winning the blockchain world. If we're going to have a situation where several players are still present, maybe with their own specific use case, and in this case, you really want them to be able to communicate with each other.
Yeah. Yeah, I think like the only reason you'd ever consider it to be a short-term consideration is if you actually believe there's just going to be like one blockchain to rule them all, which I think it's pretty clear that that's not going to happen, and it's clearly not the case. Like there's so many different layer ones and different like application-specific blockchains out there that it's clear that it's not just going to be, you know, one blockchain, and so all of these different blockchains are really going to need to communicate with each other, which is the core of interoperability. So yeah, I definitely don't think it's a short-term consideration.
Maybe on that topic, could you explain a bit why is it so useful to have multiple chains and to have interoperability between those chains?
Well, I mean, different blockchains might serve different purposes, so they may like excel in one thing. I mean, in the Cosmos ecosystem, the idea is that you have application-specific blockchains which are tailored to be really good at whatever application they're trying to do. And I think this is kind of thinking like not just in the blockchain industry. Like I think lots of small pieces connected together, at least from my background, seems to work more effectively than having like one massive piece that's more like slow and inefficient. So I think by having things which can be tailored to be specific to a specific application and then allowing them to communicate better, it gives a bit more agility, and you can be like developed in the best direction for the specific application. So I think it's just going to be important for like from an end user's perspective, because you're going to get better utility from each of those blockchains rather than having one thing which is trying to do everything and maybe not succeeding in doing all of those things well.
Yeah, thank you very much for this answer. Would you say this is also the reason that Lisk has gone for this interoperability route?
I mean, definitely we're in a similar situation where chains in our ecosystem are supposed to implement a specific application. But to link back to what you said, I think this was also one of the original reasons of interoperability, this agility that you said, like being able to play around with your chain where, you know, maybe there is not so much value stored, destroy it, crash it, get in hacked, whatever. Eventually somebody is going to develop a good chain with a good application, and interoperability gives this independence between chains so that really you are able to experiment as much as you want without, you know, doing it in a production critical chain, for instance.
And so, expanding on this, developing a blockchain project or developing a smart contract, like we also just saw in the last talk, is extremely difficult, and there are lots of things that could go wrong. We have also seen in the news quite a few hacks in the recent months. Could you talk a bit about the challenges that go into developing an interoperability solution, and how would you say that are the best way to tackle those challenges? Maybe Susanna, if you want to go first.
Well, I guess there's firstly like a technical challenge that all of these different blockchains are different and unique. So they're not like by default speaking the same language, and yeah, there isn't interoperability by default. So that's just a technical challenge in ensuring that, you know, a blockchain with a virtual machine over here can communicate with this blockchain written in another programming language. And then beyond just that kind of baseline challenge, I think when we think of interoperability, people are often thinking of like bridges, for instance, which is, I mean, like it's where there's been like a lot of exploits seen. That's why I think interoperability might get like a bad reputation. But so with like these kind of interoperability bridge designs, there seems to always be trade-offs between like security or like speed of your transaction going from one blockchain to another, and generally like how far the interoperability protocol can go, and like you might have to then do like use multiple different interoperability protocols to get to your end destination. So like that's kind of like a constraint of how far that protocol is actually going to take you. So yeah, it's like I think there's constantly these trade-offs that people are having to consider. And I think a lot of people go for like the quick and easy solution of like using a multi-sig, for instance, which is like easiest to deploy, but I think it's just the inferior solution. Like, I mean, the biggest exploit was Ronin Bridge, which was like a 5 of 9 multi-sig, I think, and $625 million is lost through that like easy and quick bridge design. So yeah, I think there's always these trade-offs that need to be considered, but I think there's some which you shouldn't really trade off with, but you know, that's my opinion.
So somehow trading some security for some scalability, but making sure not to go too far in that direction. Yeah.
Yeah.
And it's also trading, apart from scalability, for ease of implementation, as you said, right? Because, of course, again, what we were saying before, you have to import the state of a certain chain to your chain. And in doing so, you know, if your chain are heterogeneous, you need to build a protocol that is understood by both chains. And in many cases, this could be challenging. Or, as you said, the quick and dirty solution, have a multisig. Everybody knows how to make multisigs. But in that case, you trust these intermediaries that more often than not, are really the weak point in the interoperability chain, in the bridge.
Yeah.
Okay, and so here you have a whole game of trying to incentivize those intermediaries so that they would keep on behaving in the same way that they should, and so that the whole network as a whole like stays secure, right?
Well, I guess like when I'm thinking about like the trade-offs in security assumptions, like using a multi-sig bridge is using like a separate security assumption than the underlying blockchains themselves. This is just trusting. I mean, in the case of Ronin, there were 9 trusted parties, and it only required 5 of them to make a transaction. So therefore, the trust assumptions is based upon these 5 people rather than the underlying trust assumptions of the blockchain themselves.
And in that particular case, weren't even 4 of those signatures held by the same entity somehow?
Yeah.
I think one was in an open API. I mean, I don't want to say something that I get sued for later on, but there was some extra.
Yeah, I mean, you're always reading like stories of like different projects which have like a single like controller of a specific contract or something like this, which is like kind of goes against the ethos of like decentralization in blockchain anyway. But I mean, it's just like a security risk in itself.
For sure.
But I think like it seems like the interoperability solutions that like, we're more concerned with don't use these kind of trust assumptions because like, you know, we've realized that that's not the optimal solution. But deploying things like a multi-sig bridge is a lot easier than, you know, programming a light client, which is going to be checking the consensus state of the counterparty chain that you're sending transaction to. So that's the trade-off, like getting something to market quickly versus something that's solid and secure.
Yeah, and that will also stand the test of time.
Yeah.
And so to go in that direction and talk about those 2 specific projects, so maybe starting with you, Alessandro, could you compare the solution that Lisk is trying to implement compared to other projects, or to compare to the one that we just talked about with a just fixed multi-signature bridge?
Yes, so maybe as an introduction, I like introductions. I think among several solutions for interoperability, 2 of the main ones that are nice to compare and contrast with each other are certificate-based solution versus sharded state machines, basically. So certificate-based solution, you know, in a nutshell, you have a collection of chains that work independently from each other. They have an independent consensus layer, independent set of validators that validate blocks and update the blockchain and can revert the chain if necessary. In a sharded state machine, instead, you have the situation where all chains, call them parachains for Polkadot if you want, or shards for Ethereum, they kind of share the same state and the same set of validators on the main chain. So in this sense, Cosmos and also Lisk are certificate-based solution. And the idea there is that, to go back to the security assumption again, the security assumption is based on having, I'm going to talk in broad terms here, security on both sides. So you have to trust validators from one chain and validators from the other chain. In a sharded state machine, all validators are just the same set, so you have a single point of failure if you want. I mean, it's not a bad thing. I'm just saying it with these words, let's say. For Lisk specifically, we implemented interoperability. Again, currently it's only for chains within our network, so they are developed using the Lisk SDK. And the way in which we do this, it's by implementing an interoperability module that you can include in your application layer, basically, like any other module, like the token module. And this interoperability module will provide you the basic functionalities that you need to communicate information about your state to other chains. And the paradigm is really just that of having certificates containing the state root of your chain. So, a condensed version of your state, which is cryptographically authenticated, signed by validators, and posted on the other chain. So the other chain trusts this set of validators because technical reasons. And together with this, state root commitment, if you want, you can post all the necessary information that you need to process the state transition on the receiving chain based on the state of the sending chain. So this is, in a nutshell, what we do. So one interoperability module, you add it to your chain, and then you can join the network.
So yeah, maybe before going into more comparisons, Susanna, could you also talk a little bit about the Cosmos solution or the IBC solution?
Yeah.
And how it compares?
Yeah, so the IBC is basically made up of two components. You've got the transport layer and the application layer. So the transport layer is concerned with getting the data from one chain to the other, and the application layer is concerned with what you do with the data when it's sent to that chain. So two important parts of the transport layer are the relayers and the light clients. So the relayer is it's a permissionless role, like anyone can be a relayer, but often specific, like actors like other validators might want to be relayers, but it's permissionless, anyone can be a relayer.
And would you get incentivized for being a relayer?
So currently the way that relayers are funded is through a number of different mechanisms. Sometimes blockchains will pay relayers directly for providing a service, or they might give out grants or reimburse the fees on either side of the blockchain for submitting these transactions. But actually we're launching, it should be ready this summer, a fee middleware. So you can then basically add this to channels, and then this will pay for a packet to be sent from one blockchain to another. But that will be live shortly, but it's not quite live yet. So currently it's through other means, not directly on chain. But so to go back to, you have the relayers and the light clients. So the relayers are kind of observing for whether a message on a sending chain has been sent, has been decided to be sent and wants to be sent to the receiving chain. And then the relayer will submit a proof to the light client on the receiving chain to check that this message is valid and was actually sent. And then once they confirm that, then they'll send the message, the data packet, which is just opaque to the relayer. It's just bytes. They'll send that to the receiving chain. And then the application module on the receiving chain will decode this data packet and do whatever it's meant to be done with it. So the most common application that's currently used is token transfer. So there's a specific module which will take this packet and transfer the token, lock tokens on one chain, and then have them sent to the other chain. But this is just the kind of standard use case for interoperability. I mean, there's so many other cases. There's sending data from an Oracle chain in the case of band protocol, and recently launched is interchain accounts, where you can control an account on one blockchain from another chain through sending messages. And there's other things coming as well, like cross-chain queries and NFT transfer. But so not just token transfer, it's basically just a generic message sending protocol.
You can trigger any state transition in the other chain by sending a generic message that contains the instructions directly.
Yeah. So basically just dependent on what is in the application module, you can have lots of different use cases.
You could trigger a smart contract execution directly from another chain, for instance.
Yeah, with interchain accounts. Yeah.
And you would just need that the sending and the receiving chain know about this module or this feature set, and so they can create the necessary request.
Yeah, so you'd have to have the module on both chains, and then you'd have to have this authentication module for one chain to be controlling the other chain, but like it's a functionality which is possible.
Okay.
Yeah.
This is very similar to also Lisk solution, right? Where you can add modules to your sidechain, and then if you have a common module between two sidechains, you can exchange messages for this module.
Yes. Basically, I think something that we don't do is registration of channels specifically, because I think you do module-to-module channel registration before being able to communicate, right? To
So we
be sure that you really...
Yeah, so for a specific application, you will have like one channel between the two chains, which is, so say if I had between two chains, I'm sending a specific token, there would be like a dedicated channel for that specific application.
So that packets in
each
channel are basically only, I think it's a, how do you say? Like it's a queue, like you first have to process packets in order. You have to process packets in order in the channel, or?
So channels can be ordered or unordered.
Okay.
It's dependent on the specific application.
But the queue is per channel, basically, rather than being just a...
Yeah, but so for a specific like application use case, you will have one channel open, which all the packets for that specific application will go on that channel.
Okay. So sorry, hijacking of it, but the processing is not necessarily in the same order in which the packets were emitted, but rather if packets are emitted for different channels, or rather...
Well, so that depends on like the specific channel.
Okay, you can decide.
As to whether you want to have like an ordered or unordered channel.
Okay.
Very nice. Very nice. So maybe just to conclude this comparison question, if in one sentence you could both, let's say, compare your project to the Ethereum sharding solution, what would you say would be the main takeaways that would promote your project? Yeah, maybe if you want to start.
Guest first.
Well, the whole like idea behind having IBC connecting all of these sovereign blockchains that are application specific is so that each blockchain has like more autonomy. So like as we mentioned before, like they can upgrade their blockchain whenever they want. It's not like dependent purely on Ethereum. So there's like more agility and sovereignty for each blockchain to do what they want to do. And each blockchain can like customize for a specific application. So for example, Osmosis is like the largest decentralized exchange in the Cosmos ecosystem. And they have plans to customize the consensus layer so that they would use threshold decryption, so that then basically you only reveal the contents of a transaction when it's actually executed. So this is kind of like a front-running minor extractable value resistance like solution, because this is a DEX and it has loads of liquidity pools. So like it would be like a specific use case which is important for that blockchain, but for a blockchain which doesn't have a DEX on, it doesn't really matter so much. So why would you need that? So I think the main like benefit is to say all of these blockchains can be tailored for a specific application, but they're still all connected and seamlessly integrated with each other. Whereas Ethereum, you have like a very large blockchain, and you don't get to make those kind of like, you can't just decide to upgrade the Ethereum blockchain. Like that's not possible.
Much more difficult.
Yeah.
Yes, I would maybe say something similar. And again, it's going back to the previous comparison, right? At the end, it's a matter of trade-offs. We're trading agility, scalability also in a sense, because the network can grow, I won't say arbitrarily large, but we have a different sense of scalability, let's say.
So
and the trade-off...
You would say the scalability for Lisk would be greater than the one for sharded Ethereum?
I would say in general versus sharded machines, certificate-based blockchains are more scalable in the sense that you can have more chains participating in the network, just because you have more validators, if you want, at the bottom line, right? So instead, in Polkadot or Ethereum, at the end, the set of validators is centralized, so they can only run so much code for each block. And yeah, so I would say we also took that trade-off in terms of scalability versus, I don't want to say security because it's not necessarily true, but in terms of centralizing validation and consensus. Let's put it this way.
Okay, thank you. So maybe to continue, so this topic has seen a lot of hype recently, and there are lots of efforts to promote it and to improve it. So in your mind, or in your opinion, what is the most exciting area that the interoperability is going into, and how do you see this coming along in the future? Maybe starting with Alessandro this time.
Yeah, so on a personal level, I'm just excited that our hard work in the last year and a half, will see the light of day. All the effort that we put into specifying the interoperability protocol is currently being implemented. As Ishan said, we tagged the first alpha version. And I'm just excited that this is going to be actually there, and people are going to use it. In terms of the general direction of the industry, again, I think this is a necessary step that we have to take. And future will tell what will be the killer app for blockchains, right? Apart from interoperability. But I think the interoperability is going to play a role in this, just because I really think that we will, as you said before, we will not have the blockchain that fits all solutions, but rather have a very diverse field. And it's like the World Wide Web in a sense, right? You have computers that are good at something, programs that are good at something else, and when you put them together, you create something emergent and completely new. And I think that is really what excites me the most.
All right. And from your side?
Well, yeah, I mean, I think it's similar. I mean, I think I'm slightly biased that obviously I have more of a vested interest in IBC personally. So obviously I'm excited about the new use cases of IBC that's coming. So yeah, and I think something that excites me the most is not just having IBC within the Cosmos ecosystem. I think the Beefy client implementation to connect IBC to Polkadot and substrate-based chains is really exciting for me. Just think having a kind of just a more of a universal transport layer is just exciting to see actually panning out. And
okay.
Yeah.
So maybe a bit more of a controversial question now. So I think you're both saying that what's really exciting is IBC and or Lisk interoperability and the fact that chain will communicate and that this communication will also expand across ecosystem in the future. So then my question is, how important will be the base layer 0 chain in the end? So the Lisk main chain or the Cosmos main chain. Once everything is set up, maybe you could have a few words on this.
Yeah. Well, I think if the end goal is kind of a world of blockchain mass adoption, no one will actually really care what blockchain they're actually using. I think a metric of success in the blockchain space will be when people are just using the blockchain without realizing they're using the blockchain. So at the end of the day, I don't think people will, especially for a mass market, I think in general we kind of probably all agree that the user experience of blockchain generally is pretty dire. And you can't just tell your mum to oh, just send me whatever this token. It's not so simple. And especially if you're telling your mum to send me this token from one blockchain to another, it's basically not going to happen. Unless you've got a really, tech-savvy mum. But not that my mum isn't. But yeah, I think it's just the user experience is not good. And even for people that work in the space and interact with blockchain, you can still come across difficulties in doing what you want to do. It's not, I don't think it's simple or easy. So I think success will look like not even having to worry about like, you know, addresses or things like this, which aren't really human friendly. So I think like people in the end state shouldn't care about that kind of thing. It should just work. And like the internet, you know, it just works.
Should just work.
Yeah.
Next slide, so you put, it should just work.
Yeah.
Yeah, it's the dream. It's true that when you connect to the internet, you don't care to which server you're connecting or where your website is hosted or all those kind of things. Yeah.
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 Would you be of the same opinion? I'm pretty sure.
I completely agree with you. And what you said, especially like that, you know, at the end, it's going to be abstracted away for the user if ever this becomes successful. And of course, the key here is bringing it to the same experience level as paying with your banking app or whatever you use, but with the, you know, security, decentralization properties of blockchains, which is kind of what we are trying to do, right?
Yeah.
So basically, we're working very hard to make blockchain disappear.
Well, to become invisible, but not disappear.
Don't disappear, yeah.
Yeah.
Which is different.
Yeah, it's slightly different.
Can do questions, I guess?
Yes, definitely. We could do some questions from the audience. We have a few minutes. So, any questions? We have a mic here that can go around. And
one question, just to make sure I really got the grasp of the whole idea here, is when we were discussing before the bridges and exploit of those bridges, the solutions that you are now presenting would come to replace those bridges?
Oh, yeah.
Okay.
So, yes, thank you. I hope everybody got the question. So, basically asking if the exploits that we had about the bridges would be mitigated because we would replace those bridges by stronger solutions. So maybe, Susanna, if you want to answer this question.
So I'd say, like, in the long term, yes. Like, the reason why you have, like, well, in my perspective, why multi-sig bridges and stuff exist is because it's just easy to deploy them, and you might need to move tokens from one chain to another, or you might want to connect your chain to Ethereum or whatever. But I think long term, there are much better solutions. Like, our solutions could serve this purpose, for instance. So yeah, I do think that's like the long-term intention.
So you could really think about it in terms of replace multi-sigs with light clients. I don't know.
Yeah, yeah.
And I have a particular problem with this type of bridges of nowadays is that for me there is no transparency on how long it will take for the bridge to complete. So you send money to one wallet on one chain, one blockchain, and you don't know when it's coming on the next one. Some of them even put like alpha forever, so if something bad happens, your money disappears and you don't know, you cannot complain. How transparent would be those new solutions that you were just discussing for the end user?
So maybe Alessandro, if you want to jump on this one?
Sure. Again, first rule is to be careful and know what you're doing, of course, like in everything. So at the end, with interoperability, there is something you cannot escape, again, is that you are trusting different parties, right? To be sure that your transaction is actually happening from one chain to the other. You're trusting the validators on chain A and the validators on chain B. So if you cannot trust the validators on chain B, I mean, it's not going to work ever. Like, that's really something that you have to assume that somebody's not agreeing with me. But and instead of, maybe if I understood your question correctly, in terms of timing, like how to be sure that eventually your transaction is going to show up on chain B, was that the question?
Yeah, if I could tell how long it would take, because I can see my funds or my tokens going from my wallet to the next wallet in this blockchain, but I don't know after it changes the blockchain, what's the process, what step the transaction is. So it can take 10 seconds, 10 minutes, I have no idea.
That depends on a lot of factors, like block time on both chains, or in the Cosmos ecosystem with IBC, but also for us, when you have these relayers, you have to wait for a relayer to do it. But as Susanna explained, like, you could be your own relayer if you really want. So you have some degree of control over that, right? Like, you can make it happen because you can always post your own transaction in the other chain. To have a system that works seamlessly what you really want probably is to many people pool resources together so that a relayer can submit a bunch of transactions all together, getting a discount on the fee. So in that sense, you have more complex systems like fee incentivization and so on. So it really depends on a lot of factors, let's put it this way.
Yeah. Yeah, I think like the time it takes is like a function of the bridge design, but I guess like the thinking is, yeah, you'd have to have like the block time on both sides, and then the time for like, with IBC's case, the relayer to actually like send the data from one blockchain to another. And I mean, for the case of IBC, it's like often like not more than a minute, like could be between like 5 to 30 seconds, something like this.
But does the end user has visibility on that? Like, do you send back, like, this is your transaction ID, you can check there on the new chain?
Well, when you like get the transaction hash, you'll be able to put it in an Explorer and check that it was executed. But yeah, I think like the concept that you raised of like self-relaying with IBC, like in theory, you can just relay your own transactions, so then you have total autonomy over like how quickly you want to like send your own message. And this is something that is in development, of having like a TypeScript-based client so that you can relay your own transactions. But
yeah, because probably in the end, the normal flow would be that you wait for the pooled relayer to just move your transaction without you having to do anything, but your wallet could also offer functionality where you just click and say, I want instant relaying, and then you take care of the relaying. But then you would have to pay the transaction fee yourself, but it would be as fast as you wish, probably. Yeah.
Thank you.
I see that we are out of time, so I will thank again Alessandro Riccotone from Lisk and Susanna Evans from IBC and from Interchain, I'm sorry. And I think you will stay with us for a little while to have some food and drinks, and so everybody is very welcome to ask any further questions to them at that point. Thank you very much.
Thank you, Maxime.